Hi, we're going to be working with solving absolute value inequalities for the third day. Let's start with our bell ringer. We have 4 problems to look at. For the first problem, I consider the value. We have a value of 4. Is it possible for a distance to be greater than 4? Absolutely. I'm going to solve the problem using algebra. The way I solve the problem, we're looking for g is greater than 4, and the opposite of g is greater than 4. The word that separates these two for a distance that is further away from 4, we will look at or. The first example is already finished. For the second, I will divide both sides by -1. And don't forget, you're dividing by a negative, you must flip the symbol. So our solution in set builder notation, g is less than -4, or g is greater than 4. I will have 2 separate intervals going in opposite directions. My final answer, from -infinity to -4, union 4 to +infinity. For example 2, I'm looking at my value. It is a positive value. Is it possible for a distance to be less than 10? Absolutely. So I will set up my 2 problems. A plus 4 is less than 10, and the opposite of a plus 4 is less than 10. We're looking for the values that are less than 10. We have an AND problem. I'll solve the left-hand side by subtracting 4 from both sides. A is less than 6. I choose to divide both sides by -1 right away. We will have a plus 4 and -10, but because we divided by a negative, we must flip the inequality symbol. To finish solving, I'll subtract 4 from both sides again. A is greater than -14. In set builder notation, you could write it as a is greater than -14 and a is less than 6, or if you consider flipping this inequality around, you can write it as an extended inequality, which leads straight to interval notation. Let's look at problem 3. Is it possible for a distance to be less than 2? Absolutely. So I will write my 2 complete sentences. 3 minus m is less than 2. The opposite of 3 minus m is less than 2. We're looking for distances that are smaller. That's an AND. To solve this problem, I will subtract 3 from both sides. Keep in mind, that's a -m is less than -1. We will divide both sides by -1 and change our symbol. M is greater than +1. For the right-hand side, I will divide both sides by -1 right away. 3 minus m is less than 2. Sorry. I was about to remind you. Don't forget to flip the inequality because we're dividing by a negative. I will subtract 3 from both sides again. Negative m is greater than -5. We're dividing by -1 again. Change the symbol back. M is less than 5. An alternative would have been to distribute the negative, and then you would not have to reverse twice, because that would be -3 plus m. But this is the process that I usually follow for all problems, and it works for me. In set builder notation, m is greater than 1, and m is less than 5. If we flip this one around, 1 is less than m, and m is less than 5. You can write it as an extended inequality, which leads to our interval notation. For problem 4, this is not ready to solve. What I must do is subtract 7 from both sides first. I will take the absolute value of 2/3 x is greater than or equal to -4. This is a special case. Is it possible to have values, a distance, that is greater than -4? You betcha. All distances must be greater than or equal to 0. It has to be positive or 0. Therefore, all numbers will work. All real numbers work. In interval notation, that's from -infinity to +infinity. That concludes our bell ringer. On the reverse side of your bell ringer, you will find the notes. Please watch the next video for the notes.